Welcome everyone. My name is Benjamin Welle and I'm the Director of Energy Lab at Perkins and Welle. And today I'm going to quickly provide an overview of a technology platform called SPEED we've developed as a first pass at addressing many of the challenges of institutionalizing early stage energy modeling for effective design guidance. But first, some context of what I believe our new norm will be. First, the Jaws effect. At its core, the fear of being attacked by a shark is due to a person being in medium water they have no control over, a perception of unseen threat, and that threat could cause significant harm or death. Sound familiar? People return to the workplace. They will face the same, but that medium will be air. Owners face new risks of reduced worker productivity, worker safety, and potential for litigious action. How will they respond to these new risks? Well, HVAC is about to get a lot of love. And it's not just about discomfort or high utility bills anymore. It's life or death. There'll be a shift to vertical low airflow systems, and previous cost premiums will be irrelevant to owners now. And it just so happens the viability of these systems are much more tightly coupled to the building envelope, such as massing, spatial layout, fenestration, lighting design. Thus, architects must account for these complex interactions using simulation early and often. Achieving Architecture 2030 is already unrealistic, but we really need to think about the absolute carbon emissions and account for the dramatic increase in energy use in the existing building stock due to COVID and HVAC safety measures, increasing the need for more aggressive energy efficiency measures in the future. Most of us have seen the McClamey curve before. However, the current state of most firms is to have simulation applied to those early stages at only a few points in the design process at best. That does not provide effective design guidance. Ideally, you have use rapid modeling that's useful for design guidance early and often to make those decisions, even in the pursuit stage. Modeling during the later stages of design should be primarily for compliance. When you employ large-scale simulations with statistical analysis, during those early stages, the user can evaluate many dependent variables at the same time, understanding their interactive effects required to provide that design guidance. And it also tends to wash away much of the uncertainty in the assumptions required during early design. You are able to take the process laid out in, say, ASHRAE 209 and make linear cycles parallel ones and move the entire process upstream. SPEED is one attempt to address the previous challenges. It is a web-based, cloud-based design and analysis platform for energy and daylighting enabled by a high degree of innovation built in under the hood. It's an example of simulation as part of a technology platform rather than just a simulation tool. It was designed to be an ecosystem for AI. With so many uncertainties during the early stages of design, such as assumptions and novices behind the wheel, a high degree of design automation and intelligence is critical to the platform's success. We constantly seek to balance simplicity with effective integrity. Here's one option for generating design options: pre-parameterized shapes to evaluate various building forms. We auto-perimeter core zone. At any time, GBXML or radiance files may be exported for use in other applications. Using the block and stack tool built upon NRL's floor space app, the user may also draw custom geometry with the rules of energy models built into it for perfect conversion. Quickly draw your building spaces, assign ASHRAE space types to Untitled 24, duplicate, move, create new stories, and draw any site context that you want. On the envelope page, you can evaluate fenestration and shading configurations very quickly. You can run a shadow analysis, generate a sun path diagram, run solar studies using a novel radiance-based simulation method that we developed that dramatically reduces simulation time and improves accuracy over conventional methods. Intelligently assign HVAC systems based on project profile and automatically apply 90.1 prescriptive requirements. But SPEED's true power resides within its parametric study. The user can quickly select which design variables and options they want to study. They click Run, are converted to energy input files for Energy Plus and Radiance, passed to Open Studio Server, run in parallel. The results are parsed, stored, and post-processed. The results are then shown to the users in a series of interactive visualizations: single run, multiple run charts, PCPs, 2D and 3D scatter plots with features such as viewing the building forms rather than points, preference shading, assigning constraints, and then simple yet powerful charts using global sensitivity analysis and multivariate regression to understand the most important design variables and their dependencies, what is what you don't get from point-based simulation. This is true design guidance. Another recent milestones for SPEED. This year we had a DOE success story published for a collaboration with NREL on SPEED, which we are quite proud of as we are the first architecture firm to have done so. We've been approved for Architecture 2030 reporting and the DDX list. We meet the requirements for LEED IPC1 integrative design process for early stage energy modeling. And to date, we've run over 130,000 and 100,000 energy and daylighting simulations, respectively, on over 100 real projects. SPEED in its current form is just the first couple of steps towards what will be in the future, what I like to call a lifecycle platform. A lifecycle platform is one that is used by all members of the project team throughout the design process by functioning as a parent platform, dynamically evolving based on the user experience and the design phase, exposing different functionality based on those criteria. A lifecycle platform is also a data center communication and collaboration coordination platform between architects, engineers, consultants, and clients. As SPEED uses the same engines as most commercial energy and daylight modeling tools, the consultant can easily transition to a more detailed simulation tool of their choice as the design process progresses and the situation requires it. Those results may be pushed back to the parent platform for further iteration, including client engagement. Over the past 5 years, we've had a very diverse and highly skilled development team working from architects to programmers, PhDs, energy and daylighting simulation experts, visualization gurus, and collaborations with industry, academia, and government labs. A special thanks to Dr. John Haymaker, our Director of Research, Amir Roth at the DOE, and the Research Advisory Board of Perkins and Welle for their unwavering support for this project. If you'd like to get more information on SPEED, you can go to the following site, datadrivendesign-speed.io. And with that, I'd like to thank you for listening to this Power Talk, and I look forward to any questions you may have.